All right, our next speaker is Dr. Jonathan Rathsam. He is a senior research engineer at NASA's Langley Research Center in Hampton, Virginia. He conducts laboratory and field research on human perceptions of low noise supersonic overflights. He currently serves as technical lead of survey design and analysis for the X-59 community overflight phase of NASA's Quesst mission. He also serves as co-chair for Team 6, Community Response to Noise and Annoyance for the International Commission on Biological Effects of Noise, and previously served as NASA's co-chair for DATAWorks. He holds a Ph.D. in engineering from the University of Nebraska, a BA in physics from Grinnell College in Iowa, and completed postdoctoral research in acoustics at Ben-Gurion University in Israel. Please help me welcome Dr. Rathsam.
Thank you so much for the introduction, and good afternoon, everyone. Thank you for persevering here after lunch, the home stretch of DATAWorks this year. In a few years, NASA is slated to begin a nationwide community survey. The goal is to understand how people respond to the sound of X-59, a one-of-a-kind experimental aircraft that's designed to mitigate the sonic boom during supersonic flight. The results from X-59 are going to generalize to future supersonic aircraft. And this talk right now focuses on a survey methods test that was conducted last fall. Thanks. Let's see, I'm going to see if I can move something out of the way on my screen here. Okay, perfect. NASA selected a contractor team that was led by Harris, Miller, and Hansen to plan and execute the community test campaign with X-59. So now I'd like to acknowledge HMMH and their subcontractors, Westat and EnviroSuite, for conducting this survey methods test. Just in terms of an outline here, I'll begin by talking about the structure of this community survey and then some of the key challenges that needed to be overcome in order to collect the survey data, and then conclude with some of the lessons learned. The overall goal of this Quesst community survey is to estimate a dose-response relationship that's shown here in the plot. Sound levels from X-59 are on the horizontal axis, and the annoyance levels from the survey are on the vertical axis there. For this survey methods test that I'm going to describe, there were no X-59 overflights, so the survey questions targeted commercial aircraft noise rather than any sort of X-59 noise. No attempt was made to quantify the aircraft noise exposure for this test, and no dose-response relationship was estimated. The community survey consisted of the 5 separate surveys that are shown here. The first 2 surveys were conducted as part of the 8-week recruitment phase. First was the household screener that targeted household recruitment. It was followed by the background survey to recruit a selected individual from the household. And then individuals were considered recruited into the survey after they had completed that background survey. Moving to the middle of the chart, the single event surveys were conducted multiple times each day over the course of 4 weeks at each noise event that would mirror an overflight of X-59. There were a total of 76 single events across the 4-week period. The daily surveys were conducted at the end of each day, and there were a total of 23 throughout the 4-week period. An individual was considered a participant after they completed at least one single event or daily survey. Then finally, we had this end of test survey, and that assessed overall reactions and annoyance levels to the noise events during the study. And participants were given 2 weeks to complete that end of test survey. This slide shows several of the key challenges that needed to be overcome. And these included recruiting a representative sample, conducting surveys when the responses are needed in a short time after each overflight, assessing the location of each survey participant in order to accurately estimate their noise exposure, and then maintaining the participation across multiple weeks in a somewhat intense survey environment, potentially many surveys per day. We're going to start at the top, recruiting a representative sample. Each survey sample here has to be representative of its locality. So how do you recruit a representative sample of people from a large geographic area? We're talking many hundreds of square miles that X-59 will overfly. Address-based sampling was chosen to recruit a representative sample in the Nashville, Tennessee area. Nashville was chosen because it had a sufficient population. It had mixed population densities, so ranging from dense urban population to suburban to rural. It had typical levels of internet access, and it also had the presence of commercial aircraft noise. In the map on the left here, the inner box there is 20 by 30 nautical miles, which is the size of the area that X-59 is going to overfly. 5,000 residential addresses were selected from census blocks that fall fully within that inner box. And then a random start was chosen and units were selected at constant intervals from within those blocks. The table on the right shows the dates of the different recruitment mailings over the 8-week recruitment period. So you can see at the top there that we started out with an initial mailing that went to 5,000 addresses, and then the subsequent mailings went to fewer households as people were recruited into the survey. And then finally at the end, the recruitment yielded 800 people who signed up. And the results show that the distribution of both recruited individuals and participants was largely representative across these demographic groups. The plots here show the distribution for race on the left and age on the right. And the red bars are estimates of the proportions based on Census Bureau estimates from the 2018 to 2022 timeframe. The blue bars show estimates based on the 800 recruited individuals, and the gray bars show the estimates based on 602 participants that completed at least one single event or daily survey. While the distribution doesn't perfectly mirror the underlying population, the demographics are nearly the same. The distributions for other population subgroups like education, ethnicity, and home ownership are also similar. Discrepancies like the ones that you see here are common in survey research, and any demographic disparities are going to be adjusted via statistical weighting in the analysis phase. So moving on to the next key challenge here, the short time frame. Prompt reactions are needed on the scale of minutes after an overflight. So how do you assess responses that quickly after each overflight? The X-59 mission is designed for up to 2 supersonic passes over the community before the aircraft returns to its base. And that means on the order of 20 or 25 minutes between supersonic passes. So to ensure that the survey responses correspond to supersonic overflight noise and not to other sounds, and also to ensure that they correspond to the correct pass, the online surveys for the single events are open just shortly before each simulated pass. For the single event surveys, the response time was relatively short. You can see on the left there, 50% of the responses occurred within 17 minutes, and 75% of the responses were completed within 60 minutes. And for the sake of comparison, we're showing daily surveys on the right there, even though those aren't quite as sensitive. They're not time sensitive, really. So the 50% of those daily surveys were the responses occurred within 30 minutes, and 75% of the responses were completed within 90 minutes. The respondents had a choice whether to respond via a website or via a smartphone app, and 42% of the users used a smartphone app at least once. Now to the next key challenge here, which was location. I mentioned earlier, in order to estimate X59 sound level, you have to know the respondent's location. So how do you collect location during an overflight, during the survey? Survey respondents were directed to enter their location at the time of the overflight in an interface similar to the one that's shown on the left here. They were given the option of choosing pre-populated locations like home or work, or they could insert a street address or an intersection, or they could drop a pin on a map, like the one that's shown. If they couldn't respond at the time of the survey, they were allowed to respond until the end of the day. And the plot on the right shows some of the results. This is the density of respondent locations for all the surveys on all of the days. The majority of locations are within that inner box, but you can see that some of the locations are clearly outside that inner box. The home residences were targeted, to be within that inner box, but people could have work locations that might be outside the box, or they could be shopping or visiting friends, any number of reasons they could have been elsewhere. And then the last of the key challenges here, maintaining participation. So to allow time for a community to get used to a new sound, like the sound of X59 overflights, the survey needs to last for multiple weeks. How do you maintain respondents' participation across 4 weeks for all of these supersonic overflights? This scheme shown here, graduated survey incentives, was developed in order to maintain the participation across the 4-week study. Each week, the respondents earned an incentive that was based on their level of survey completion. So if you take, for example, see if I can highlight one of the rows here as an example. Take this week 1, 0 to 49% of surveys complete, there's no incentive. But if you completed between 50 and 74% of the surveys, you got $25. 75 to 99% of the surveys, you got $35. And if you were an overachiever and you did all of the surveys, you would get $45. And then in the subsequent weeks, these incentives increased by $5 each. So a participant who completed 100% of all the surveys could potentially earn $240 in incentives. The incentive scheme was successful in maintaining participation throughout the survey. As you can see in the plot here, the single event survey response in blue was consistently between 40 and 60%, and then the daily survey in red was consistently above 50%. There's an interesting detail you may notice when you're looking at this, that the single event surveys toward the end of the day tended to have lower response rates than earlier in the day. And this was probably due to less time being available to respond to those surveys before they closed at the end of the day. And something that's not shown on this plot is that for the end of test survey, 67% of those surveys were returned. For situational and awareness, a user interface was developed to report single event survey responses in near real time. They were geolocated on a map as shown here. And as you can see from the legend, the warmer colors indicate more severe annoyance responses. Here, I'd like to just walk through some of the lessons learned that will improve the surveys that are conducted when X59 is flying and overflying the communities. And let's start in the top left with survey operations. The response rate to the very first single event survey was lower because the respondents had some issues getting back into the system. They might have been recruited weeks or possibly months earlier. And so there was instances of forgetting passwords and forgetting how to access the system. And so the contractor team recommends a self-service option for resetting the passwords. The contractor team also recommended better visibility for the frequently asked questions in the mailings, and also emphasizing to the respondents that it's important to keep their incentive debit cards all the way through until the end of test surveys had been completed. If they ended up throwing their debit cards away, then they would call the help desk and they needed to have another debit card sent. So those are instructions that need to be clarified up front. In terms of survey content, the contractor team recommends that the respondents confirm that their current residence matches the address that's on the invitation letter. And this is to mitigate some issues that were observed when participants may receive mail at a location, but that's not actually where they live. Moving on to survey systems. This is not a surprising conclusion. The importance of automation in critical processes. The process for opening the single event surveys was actually a manual process, and a few surveys were missed for various reasons. So, this test here showed the vulnerability of systems to network and server problems, and points to what a critical role backup systems and backup personnel are going to play for the integrity of the operations. And then lastly, talking about that user interface that I showed on the previous slide, there were challenges in developing requirements for the survey user interface, as well as accurately estimating the time that would be needed for software testing and integration. On the NASA side, we've brought a systems engineer onto our team to help develop and track those system requirements. And just, for a very practical issue, NASA has conducted some of this type of testing in the past. One of our lessons learned from the past was, it seems obvious in retrospect, everybody needs to be using the same time, the same time zone. There's many different types of data that are being collected. You've got survey data coming in. Eventually, there will be acoustic data and weather data that are also collected. So we determined that we would use like a universal time for all of this data collection in order so that we could match up all the data. What we found during the survey test is that the time zone in Nashville, if we were tracking that in universal time, that meant that sometimes the testing was split up across multiple days. And so that created another problem when we tried to sort by which day is which. So we have, based on this testing, agreed that we will use the local time zone where the testing is occurring. And so, in conclusion here, the Quest community survey system, it did function well. It was a successful test. And this survey system is ready for integration with the other data collection systems. So thank you so much for your attention.
One question? Go ahead.
Actually, so how are you going to, baseline the responses? So, for example, see whether or not, what's their response if there were no flight or?
Yeah, great question. How do we know what their responses are? For X59 relative to other sounds, for example, there are questions on the survey about annoyance levels to other environmental sounds like dogs barking or traffic or other commercial aircraft noise that there may be. So that's one way to get a baseline. And a second way to get a baseline would be to conduct a survey when an overflight doesn't actually occur. And we weren't sure whether we would be whether it would be cost effective to do these sort of false surveys when an overflight didn't occur, because that's increased burden on the respondents. But based on the results of this pilot test, we found that the response rates were able to maintain interest over 4 weeks. So it gives us more confidence in maybe asking some questions, deploying some surveys when there wasn't actually an X59 overflight. Okay, thank you.